Since each hand is a skeletal mesh, animating them is like how we might animate a character. The motion controller pawn can forward data to our animation blueprints, which will use this data to decide which position the hand should be in. For example, with our VR darts game, your hands wouldn't simply snap into a standard grip, but you could blend from one static pose to another. The fingers would be placed on each side of the dart in a more complex grip, but it would still be static. We can also take advantage of the animation graph to set up custom logic for more complex grabbable objects. Imagine the player is controlling a remote control car. You would want the thumbs and various fingers to move around, pushing different buttons individually as they grip the controller. This situation would lend itself nicely to using the animation graph to configure custom animation logic. While we won't be creating a complex system to animate our hands to that degree, we will be creating a system that will blend multiple animations together depending on if we are holding the dart asset or not, and if so, where we are along the throw of the dart. Imagine this pen was a dart. If we hold it nice and close, our hand pose is much steadier and focused as we aim. As we extend our arms during the throw, it becomes looser as we prepare to release. We're going to create an animation blueprint and various assets to support this system. Open BP Motion Controller and let's talk about the current animation of the hands from the value of grip state. Talking through this first part, the first branch is asking if attached actor contains value or the player wants to grip, and if either of those ones are true, set the grip state to grab. In this case, make a fist. If neither of those two are true, check if a pick-upable actor is close by, and if so, set the grip state to can grab. If there is nothing nearby, but we're holding the grip, set grip state to grab, and make a fist. And if the hand is not wanting to grab, and there's no nearby objects, keep it open. Immediately after, the tick will cast to our animation blueprint and update it with the current value of grip state. Open the right hand anim BP darts. If this is your first time in an animation blueprint, you'll notice that while it looks similar to an actor blueprint, there's a second graph named anim graph. Inside of the event graph is where we collect and calculate various logic and variable values, and the anim graph will take those values and determine what animation should be playing and how it should play. Currently, the animation blueprint is using its version of the event tick named update animation to determine the float value of grip. It is converting the grip state enumeration to a byte and dividing it by 2. Upon a value change, it's then smoothly animating between what it was and what it is at a speed of 7.0. See that it is using a blend space 1D to choose where on the blend space the hand animation is. Inside this blend space 1D, along the horizontal axis, or grip as it has been named, it has been given access to search from 0 to 1 with 4 grid divisions. The animation to play if the value is 0, which it would be if the grip state was set to open, as open will provide a byte of 0 and 0 divided by 2 is 0. If the state was set to can grab, it would be set to 0.5 as 1 divided by 2 is indeed 0.5. And on the very right in the position of 1 is grab. To preview the blend, hold down Shift and move your mouse around the blend space. We'll create something similar, but with an added dimension to it. Before we move on, I've replaced the can grab animation in the middle of this blend space to the can grab v2, so it feels more like we're reaching for a smaller object. And by that I mean, if I were to replace can grab version 2 back with the original can grab, you see that the hand is a bit more open, reaching for a seemingly larger object. So I've replaced it with a lightly modified version 2, so they would appear as if we're reaching for a smaller object. Create a blend space. Just be sure not to create a blend space 1D, as we would like 2 dimensions in ours. Name it right grip darts BS and open. When a new blend space is created, it's going to ask you what skeleton you want it to identify with. We're going to select mannequin hand right skeleton darts, as that's the skeleton that our hands are using. And open. Extend the axis settings and notice that there are now 2 here. Name the horizontal axis back front and set the minimum axis value to 0 and the maximum axis value to 1. Rename the vertical axis to up down and again set minimum and maximum to 0 and 1. Included in the assets are the animations holding dart up, back, down, front and holding dart up, front, down, back. This is a reference to the two locations of where we will be blending between. Place up, back, down, front in the top left and bottom right of the blend space. And place up, front, down, back to the bottom left and top right. If you hold Shift and move up and down or left and right, we can see how the animations are blending between holding the dart in a steady position versus the throw. Return to the animation blueprint and open the anim graph. Create a new bool variable named holding dart. Right-click in the anim graph and search for right grip darts BS, and you'll see that we have our two inputs, back front and up down, and promote both of them to their own variable. Back front, and this here is up down. Then drag a reference of holding dart into the graph and right-click to search for blend poses by bool. Plug in holding dart to the active value input. This node will blend between our two blends, so when we pick up the dart and holding dart becomes true, it will blend from right grip BS to our right grip darts BS. So plug right grip BS into false and right grip darts BS into true and compile. We can preview live by setting holding dart to true, and we can see the blend is happening. We could also alter the time it takes between blends, changing the values of true blend time and false blend time, but for this project, we will leave the value set to 0.1. We now have a system of controlling the animations depending on the situation. Next, we'll set up the communication from our BP motion controller to set these variables and put this system in use.